All right, the Geo crew, let's do this. So we're on lesson 3. So we are talking about triangles. So getting out those notes and rocking it out. Make sure you are on lesson 3. Lesson 3. All right, so you learned from Mrs. Briggs and Mr. Goodfellow for lesson 1 and lesson 2. And now it's Robinson's turn. We are going to be proving that triangles are congruent. So in our last unit, we were proving that lines were parallel. Now we are proving, based on these magical shortcuts, we're going to have some shortcuts in order to find that they are congruent. Okay, so we need to be very detail-oriented on how we are writing things. So let's look at postulate 1. This is called SSS, which means that if all 3 sides if they're congruent, okay, so if BC, so let's look at this example actually. So we have triangle ABC right here, and we have triangle DEF right here. And if they have corresponding sides that are congruent, then we can prove that the triangles are congruent using SSS, okay? So let's look at that. So AB and DE both have 1 dash, which means that they're congruent, okay? It's very important on how you write this. All right, so if you look at the actual triangle, AB and DE are written in that order, okay? All right, now let's look at BC and EF. Those have 2 dashes, okay? So that means those are congruent. Again, it's in that order, okay? And then the final one would be AC and DF. So if you guys notice, it's in the same order. So A, then up to C for that point, and then D to F. It has the 3 dashes. Okay, so then because of those 3 sides are the corresponding side of the other triangle is congruent, then we can prove that these triangles are congruent. All right, so make sure you say order matters. So when you're writing these for your homework, the order matters. Okay? All right, let's go to the next one. So we are going to actually do a proof. So it says a flow proof, but we're just going to go kick it old school and do our T-chart. So then we have our reasons, our statements, and our reasons. So we have our statements and our reasons, but first off, we want to come up with a plan, okay? We need to plan to see where is this going. So what I'm going to do is I'm going to look at the givens and see what they actually gave me, so then I can make a plan from there, because it says I'm going to use SSS to prove triangles are congruent. Okay, so GH and KJ. So if you notice, G to H, this line, and then K to J. Again, it's going the same direction. I wouldn't want to write JK, because then those H and J have to be congruent, and K and G are congruent. So it's really important the order you put them in. So they're saying that those 2 sides are congruent, has the little line over it, so then you know that we're talking about sides. Okay, all right, HL, so again from going H to L, and J to L, so I'm going to put 2 dashes for these, and then maybe change a color. That will definitely help. Those are congruent. So now I need to prove, what do I need to prove to get SS? Well, I need to prove that these 2 sides are congruent. Well, what did they give us? They said that L is the midpoint of GK. So going back to our notes on Unit 2, about midpoint, we can use midpoint to prove that we have these 2, so G to L and K to L are congruent. So let's write down our statements, write down our givens, and go from there. All right, so we wrote down the 3 statements, we wrote down the reasons, and they all are given. Now what do we do from there? Well, we need to be specific on what do we want, what 2 lines are congruent. So like I said, the order matters. All right, so G to L, so line segment GL is congruent to K to L. And why is the reason? What is the reason for the season? Well, the reason is because of the midpoint theorem. If L is the midpoint, that means that these two line segments are congruent. So now I can write down the two triangles. Triangle GHL is congruent to KJL. And how can I prove that? What is the reason? It's because of SSS. The side, side, side. Okay, those are congruent. So make sure when you are writing the triangles, it matters the order. So let's look at this. G and K. Do you notice that they're both the first letters? You notice up here, G and K. All right. And then what are the middle ones? What are the letters that go together? H and J, H and J. And then what are the last letters? Okay, they are L and L. So the order does matter when we write down these triangles and when we're proving. All right, so now the next one, write a flow proof for this information. Again, like G has been saying, we first need to make a plan before we just start writing things down. Okay, so let's figure out what did they actually give us. So QRS, this big triangle right here, is an isosceles. So with QR and SR are congruent. So we're saying QR, this one right here, and SR are congruent. Okay, so we know that those two are congruent. And RT bisects QS at point T. So bisector. So if I have a bisector, that means that these two are congruent. But I need to say something about that so I could prove that those are congruent. So we kind of have a game plan. So we know that at least the blue ones are congruent. I know what type of statement I need to write because of the bisecting. And then I have only one more to do, which would be this middle one. And then I'd prove that one. All right, so let's keep going. Let's keep this a train a-going. So we have our guided practice. And we are solving, so writing a flow proof. So first we should write down our givens. So we have QRS is isosceles, is an isosceles triangle. We have QR is congruent to SR because it's isosceles. And we have RT bisects QS at T. So all of these are given. All right, so now from here. So let's write down some info. All right, so we have 1, 2, 3, and this is 1, 2, and 3 is all the givens. Okay, so with this information, what can we do with it? Okay, so like I said, we need to make a game plan. So we need to prove that QT is congruent to ST. All right, so how can we do that? Well, we know something about bisects. Okay, so bisect, we know something about a segment bisector. What does that mean? That T is the midpoint of QS. So what that means is that T is the midpoint of QS based on, well, the definition of segment bisector. It would be pretty important to have all your proof information from Unit 2 because a lot of that information is going to help you in this unit and beyond. All right. Now let's talk about the next step. Okay, so let's go back. So because of that, if T is the midpoint, that means we can prove it now. So we have QT is congruent to ST. Look at the order, folks. So the T is the second letter. Okay, so make sure that the order is the same. And how can we prove that? Well, the midpoint theorem. Midpoint means that if there is a midpoint, that means that the two segments on either side that make up that segment and the midpoints in the middle, that those are congruent. All right. The last thing we need to prove. Okay, well, we need to prove that TR is congruent to TR. Well, let's go back to that yellow paper, folks. What is that yellow paper? What does that say? Well, so RT can say RT is congruent to RT based on, well, they're equal to each other, right? So that is reflexive property. On your yellow paper, it says A equals A. All right, now we proved it. Yahoo! So we need to make sure we write down the triangles correctly. All right, so if you notice Q and S, then RT, so they both have RT in it. So that order should be the same. So QRS, triangle QRS is congruent to SRT. SRT. Okay? Why? Because what are we talking about now? We're talking about side, side, side. So we were given the first two sides are congruent based on isosceles triangle. Then we proved that the next set of sides is congruent based on midpoint theorem. And then the third set of sides based on they are the exact same segment. They're exact same side. So because we proved all three sides, we could prove SSS. All right, now so example 2 is talking about a coordinate plane. So that is using that distance formula. So they want to they want to see whether these are side, side, side on this coordinate plane using the distance formula. All right, so example 2 is talking about, can you take triangles from a graph and see if you can prove if they're congruent using side, 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 okay? So they wrote down the triangles ABC. Those are the coordinate points of ABC. And then they wrote down the coordinates of EFG and drew it down, okay? So they said graph both of them. Well, that's already done for you. B, use your graph to make a conjecture. So that's like making a hypothesis. What do you think is going to happen? Well, looking at the graphs, do you think that they are congruent? So let's look down here. This one right here is flat, and this one down here doesn't look like it would be, it's as flat. So if I put this triangle on top of that one, they do not look congruent, okay? So as to whether the triangles are congruent, explain your reasoning using rigid motions. So that's a fancy way to saying that they are not congruent. Okay, if we try to put one on top of the other. Okay? So if you try to match them, they are not congruent. Okay. Now, C, it says writing logical argument using coordinate geometry to support the conjecture. So we have to prove that they're not congruent, okay? So we stated our case, now we need evidence. So C, using this distance formula, which is from Unit 1, okay, you could use these points, these coordinate points, to find the distance, okay? So for the sake of time, I wrote down the distance of each of the segments, and now we're going to talk about it. So AB is the square root of 5. So that is congruent to FG, which is also the square root of 5. So AB and FG are actually both the square root of 5, even though it doesn't appear so. All right, now let's talk about BC. BC is the square root of 8. Is there any others that are the square root of 8? Doesn't look like it. All right, and then the last one, the square root of 17, and the square root of 17. Hey, those two sides are also congruent. So AC would go with EF. Okay? However, the last side, this sides are not congruent. Therefore, you cannot use SS. and that proves our conjecture. All right, so because B and C are a no-go, they are not congruent. Okay, so you could write these 3 dots, mean therefore they are not congruent using SSS. Okay? All right. Now let's talk about 4.2. So we just used side, side, side as a proof. Now we have side, angle, side. So if you notice, the A is in between the S. The A is in between the S's, which is very important. It is the included angle, okay? So it has to be in between the sides in order for it to work, okay? So if you notice, AB goes with DE, okay? Looking at the order, okay? Angle B and angle E are congruent. And then we have BC and EF. So if you notice, again, the same order from B to C, because it is going from that angle that's congruent out, going from the angle that is congruent and then out. So then if we have side, angle, side, then we can prove that these angles are congruent. So remember, we have 3 sets of sides, right? And 3 sets of angles. Well, that's a lot of information to prove. So this is known as a shortcut. SSS was a shortcut. That was proving that they're congruent using side, side, side. And here's the next shortcut, side, angle, side. Lesson 4 is going to be more of the same types of postulates that you can prove your reasoning. All right, so the scaffolding for stage lighting shown appears to be made up of congruent triangles. So we got to look at these triangles. So let's write down the information we know based on what's given, and then we can make a plan. All right, so WX and YZ. All right, I colored it so then it was easier to kind of see what we were talking about. So we're talking about the orange one right here and the purple one right here. And then let's relabel it. So I have WXZ, and then I have XZY. And let's talk about what we've got. So we've got WX, so this side right here, and YZ, this side right here, are congruent. Okay, so that's very important that we know that. And they said WX is parallel to ZY. I wonder if parallel lines, and we learned parallel lines with a transversal, if we could solve something. So thinking about what we know about side, angle, side, and what else do we know? All right, so let's talk about this. So XZ and XZ are the exact same sides, okay? So those are the exact same sides. And let's look at the order. So W goes with Y. We've got X and then Z then X. So those are kind of flip-flopped, okay? So we really need to look at what angle do we need to prove that are congruent. All right, so making a plan. So again, we need to figure out how to prove this. All right, so we have one side. So we have the one side given. They told us something about parallel lines, so that has to give us an indication that we're doing something with angles. Okay, and then we're going to use something with the XZ and the ZX. Woo! Kind of confusing. All right, so let's write some info down and then go from there. So our statements, WX congruent to YZ, and I have WX is parallel to ZY, and we have our givens here. Okay? All right. From there, let's talk about what else we can prove. Okay, because of the parallel lines, let's remind ourselves. So if I extended these little triangles right here, okay, so my little triangles are right there, and these are my parallel lines, all right? So I want to prove that this angle and this angle are congruent because, and then let's extend this a little bit. So let's remind ourselves what type of angles those are. Okay, because again, we want side, angle, side. And we already have these angles that are congruent. Sorry, we have those sides that are congruent. Now we want to prove those angles. So what type of angles is that? So let's write it down. So angle WXZ is congruent to XZY. Okay, I put them in green over here so it's a little bit easier to see. So these angles are the same as over there. So what type of angles are those? They are alternate interior angles. Okay, so that's the theorem I can use. So anything about parallel, try to draw the picture in a different way so you can see what they're talking about. And then the last thing I need to prove, so I have side angle, I need to prove this side. All right, so how do I prove that? So I have XZ is congruent to ZX. Again, so XZ is congruent to ZX. How do I know that? Looking at the triangle order, and it's the exact same line. So what theorem can I use that kind of flips it? Okay, so that's called the reflexive property. So that's like writing AB equals BA. Woohoo! So I have one side, I have the angle, and I have the side on. So I have side, angle, side. Bada bing, I proved it. So I have WXZ is congruent to YZX. You guys notice that the XZ and the ZX is flipped. Okay, and how did I prove that? SAS theorem, side angle side theorem. Awesome job. All right, so we have this lovely triangle one to do, and then we will see how we're doing from there. All right, guys, so on the homework, you usually will have to just identify what the triangle is, so making sure you know the order of it, and then proving if it's side, 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 or side, angle, side, okay? Now, there will be a few proofs, so we want you to get used to them, all right? So we've got statements, we've got our reasons, so let's write down what we know, all right? So if f of g is congruent to gh, so fg congruent to gh, so the g's are flipped, and jg bisects fgh, well, that means something about midpoint, then we can prove that one. So we got to see what we know and then go from there. All right, so with this image, it's kind of funky to see. So I'm going to redraw it so then I know what I'm looking at. So I've got FGJ, and then I have GHJ, and I'm going to get after it. So FG is congruent to GH, and then I have something about JG bisects FGH. So that means that JG, so it says something about these two angles. And then I need to prove that this angle is, this side is congruent also. Okay, so then I can prove side, angle, side. Okay, so if you put them separately, I have side, got these two angles, and then I have these two sides are congruent. So then that's kind of my plan. So I have my givens, okay, and then I need to go from there. So number 3. All right, so from there, I need to write down my information. So I can prove that FGJ is congruent to HGJ. So HGJ, remember the G's are in the middle because of definition of angle bisector. If a line goes through an angle, that means that the two angles are congruent. So if you hear something about bisector, it's either a segment bisector or an angle bisector, okay? Because it's an angle bisector, sorry about that, we're not using midpoint. What it does is it cuts that angle in half. Let me highlight it. Cuts this angle in half and makes both of them congruent. All right, the last thing we need to prove is the last set of sides. So it's this side right here, GJ. Well, they're the exact same thing. So GJ is congruent to GJ because they're the same thing. But what fanciness am I going to use? I'm going to use reflexive property. Reflexive property. So please draw out these pictures when you are solving them. Look to make sure that you're solving it correctly. What is the order? And going from there. All right, so we proved it. So we have F, G, J is congruent to H, G, J, Y, side, angle, side. Boom. Okay, so that's how I proved it. Please make sure you have the order. You guys notice the G's and the J's, and then the F and the H. Looking at the order of how you write the triangle is super important. All right, so CPCTC, okay? What are we talking about? What does that mean? What does that mean, G? What does that mean? We're trying to prove that these are congruent. Okay, we have to prove that these angles are congruent. All right, this is the last one. So CPCTC, what does that mean, folks? So if you want to write this down, corresponding parts of congruent triangles are congruent, which means if you can prove that two triangles are congruent, then you can prove any corresponding part can go with another corresponding part, meaning that you can prove that the corresponding angles are congruent or any corresponding side is congruent based on that information. Okay, so if I prove that angle ABC is congruent to KLM, this is just an example, then I can, if I prove that, then I can say angle A is congruent to angle K. I could talk about segment BC is congruent to LM because that is the corresponding side, okay? So then you can make up the pairs and prove CPCTC. We should make it a song. CPCTC. All right, so what we're doing for this one, we are going to prove that these two triangles are congruent and then prove that these two angles are congruent using CPCTC. All right, so we've got our statements and our reasons. We're making a plan, folks. So we know that MN is congruent to PN. LM is congruent to LP. We are writing notes down. We are filling them out, folks. So given for 1 and 2. All right. Now, we need to see what else can we prove. Ooh, we can prove that LN is congruent to LN. Okay, so LN is congruent to LN because they're reflexive. It's the exact same line. Because we proved that, we can prove that these two triangles are congruent, right? So we can prove it using side, side, side. So when I already have two sides, I have to think, okay, can I prove an angle somehow? Nope, there was nothing in the given. So using the image, I can show, oh, there should be 3 dashes. Sorry, y'all. So I can prove the third side because it's the same side. All right, so I've got angles. Okay, I got to be careful on how I write this. So LMN, triangle is congruent to what triangle? So what does L go with? Okay, well, L goes with L. And what does M go with? Well, M goes with P because it's LMN. So then the other one will be LPN. Okay, so LPN will be the other one. All right, so being careful about my order. Woo! Now that I proved that, I can prove that these angles, LNM, is congruent to LNP because of my fancy little letters I have. C, P, C, T, C. Woo, woo! Corresponding parts. Corresponding parts of congruent triangles are congruent. Woo! Okay, so LNM, woo! LNM and LNP, so these two angles are congruent because the triangles are congruent. Boom. I didn't need any other theorems, so CP/CTC is a great tool to use. And then that's it, folks. So lesson 4, the next lesson will be on more shortcuts on how to prove that triangles are congruent. So thanks for sticking with me and have a great day.